Hi friends, welcome to Coordinate, and today we want to proceed in our session to understand how we can implement a stack via the use of the arrays, because they are all, of course, data structures. So we want to see how a stack as a data structure can be implemented using an array as another type of a data structure. This is why we had to discuss the arrays before the implementation of stacks, because we knew stacks would have a higher reference to the arrays. Hence, if you never watched that video, that session, please double check the description for you to have the knowledge that's needed on arrays before you implement on the basic implementation of stacks via the use of the arrays. So we can tell from here that we have a code that needs to be explained, and we'll explain this code line by line, of course, if need be, for we to understand how we can implement a stack using the arrays. So here I'm just, of course, here I just implemented the comments. The comment is something that won't be executed by the compiler and anything related to that. So we are saying, okay, I just included this as simply a basic library that needs to be included in each and every C++ learning as a program. And then here I'm saying, okay, using namespace std as a standard, of course, just allows us to work with C in, C out without the prefixing of std as a keyword before we write the C in and C out. So, and in line 8, you can tell that I'm just declaring things globally, and you can tell from here that, okay, I'm making an array with the name stack. I'm using the name because the name should be descriptive, with int as a simple data type. Of course, there are also some other simple data types, string, character, boolean, and everything related to that. Now, this array, which is called stack, should have 100 as the total number of elements that this stack should keep. And then n will hold on to 100 as the total number of elements that should be inside this stack. So I'm giving top a value as in it should equal to -1 because of this syntax that I have implemented. Here I'm saying, okay, the insertion, this we need to understand. The insertion and deletion of elements inside a stack should be done at one end. We can't insert elements on the back of the stack. Again, at the same time, we want to insert elements from the front of the stack. No. Again, we can't delete elements from the stack on the far end at the back. Again, delete elements from the front. No. These things, insertion and deletions, should be done at one end. And from the code we have the end at which we are doing the insertion and deletions of elements in a stack is what we are calling the top. Hence, the top is actually the thing where the deletion and insertion of element is being done, which is the front part of the stack. And then this is more like the actual stack that we want to implement. Of course, it has the indexes running from 0 to 99. Of course, here it's just up to 9, but you can tell that it is definitely proceeding up to 99. So this is what we are also implementing. So we are saying, okay, if we want to insert a new value, let's say a value at index 10, then top should also be at position 10, because top is, of course, the very key thing that will be denoting the point at which we are inserting and deleting the elements inside our stack. So here we are saying, okay, top should be a variable to hold the very last element in this stack, of course, which is also the array that we implemented. If we want to ask, okay, where is top in this stack? We are saying top should be at the very last element of the stack. So here is top in this array. Here is our top, or in this stack, because we are implementing the stacks using the arrays. So top is here. We have top here. I mean, top should be at the very last element of the stack. If no value is in the stack, then top should be assigned to -1. If we have no value inside the stack, if the stack is empty, this is why we are saying, okay, by default, then top should equal to -1. This is the -1 that we've assigned to top. It's because up to now, we've not started implementing the actual content that should be inside our stack, which will hold on to 100 variables. Hence, top is by default as a variable based on int as a simple data type assigned to 1, because the stack, the actual stack, is definitely empty by now. Then there are common terms that you find as we proceed with our analysis and implementation of stacks using the arrays. Some terms are underflow and overflow. Immediately when you hear the keyword underflow, the keyword under, it means the stack is empty. It is under, it has no value inside. And immediately you hear the keyword overflow, over, it means the stack is definitely full. All the elements are occupied inside the stack. That is, if we are implementing a stack using the arrays. Insertion and deletion services are done on the top variable, and the top, don't forget, should hold on to the very last element of the actual stack that is being implemented using the arrays. So this is what we are saying, and this is what we were implementing in line 8. If we proceed from our previous session, the theoretical understanding of stacks, we said push is actually a key operation which allows us to insert values inside the stack. Any value that we want to insert inside the stack should be being inserted at the point where top is holding on to. This is why we are saying, okay, elements that are being inserted will be being inserted following the top as a variable. So this is what this function is actually denoting. We are saying void push. We are saying void because this is not a function that should return any value, and push is simply the name of the function, and int val, which is shortened for value, I did so because the name should be descriptive. This is simply the parameters that will be receiving the arguments from the main function. Hence, we'll be receiving certain values which will be being held into this variable, which is based on a simple data type as int. And of course, here is the body now for this push function. We are saying, okay, if top is greater than or equal to n-1, if it is equal to n-1, or if it is greater than n-1 and n is 100. So we are saying if top is greater than or equal to 99, please display stack overflow, because it means if the top is equivalent to 99, it means we already have 100 elements inside our stack. So it is stack overflow. It means the stack is full. But if this doesn't execute to this, if this statement doesn't execute to this, if you want to understand also how the if and else statements work in C++, please double check the description. You'll be sent to the right video. If this doesn't execute, then this should happen. Now, what are we implementing here? We are saying, okay, if meaning the stack is not overflow, if we have, of course, a room to accept more elements, then top should increment by 1. And then the stack, which is the name of the array that we are using to implement these stacks, the stack at the position which top will point at should equal to the value that will come in. So if top element, and here we have a 0, so meaning stack index 0 is equal to the value that will come in. If we insert another value, then top, since top is now pointing to 0 because we incremented from -1, then it means top will now be at 1. Then we'll say, okay, stack at index 1 is equal to the new value that will be inserted. Hence, using this function, the actual function, we can now push in values inside the stack. Let's proceed on our next function. We understand more and how it can be implemented. The next function is also a function which is a void type of a function, the function that doesn't need to return any value, and you can tell the name of the function is actually pop. Pop is an operation from our previous session that definitely removes or sends out an element from the stack. If, of course, we are implementing now the stacks using the arrays. So we are saying, okay, we don't need any argument because we understand that the value that needs to be popped out is the value at the very top, because deletion and insertion of elements should be done at the top. So this is the body of the pop as a function. So we are saying, okay, if top is less than or equal to -1, then please just print out, just see out stack underflow. It means we have no value inside this stack. Why are we saying so? Because on the top we've denoted that top is equal to -1, and from our theoretical understanding we've said, okay, if no value is inside the stack, then top should be assigned to -1. So this is what we are saying, okay, if top is equal to -1, or if top is even less than -1, I mean that's -3, -6, then that is a stack underflow. Else, if top meaning is now, of course, greater than -1, then pop out the element on the top. This is what we are saying, okay, the popped element is stack top. Top is the actual index at which it is pointing at, and from here because we want also to reduce and to denote that this element has popped out, also to reduce on the size of the stack, then top should even decrement, because if that element has been popped out, then it means it is out of the stack, and then top should add the value to the element that is at the very top. This is what we even said, okay? Top should be a variable to hold the very last element, and this is what we are even saying here. Okay, since this element has been popped out, it is out of the stack, I mean pop will remove the element, then top as a variable should definitely hold to the value that's on the very top, and it should decrement down. So if this was at index 10, then now top will decrement to 9, which is index 9, because that means that is the very last element now inside our stack. Another type of a function that we can discuss is simply the function that will return, or the function that will display the total number of elements that are inside our stack. So we are calling this function, of course, display function, and it is a void type of a function. Void function, functions that don't return any value, and this is the actual body for this function. So we are saying, okay, if top is greater than or equal to 0, because I mean it means if top is greater than or equal to 0, it means top is not equal to -1, because -1 is less than 0. 0 is greater than -1. So this is what we are saying, okay, if top is greater than or equal to 0, I mean if the index is even equal to 0, then values inside the stack should be printed out. This is what we are saying, okay, see out values in this stack are, then we are using a for loop to print out the values. So we are saying, okay, for int I is equal to top, because we know top will hold to the last element of the stack. So if top is at index 20, then I will also be at 20. I is also equal to 20, and then we are saying, okay, I should be greater than or equal to 0. I should not go into positions of negatives like -1, -2. No. So the execution will proceed until I is, of course, equivalent to 0. So I should be decrementing. I mean, this is the reason why we'll be reducing on I. Let's say if top is at position 20, also it means I is equal to 20, and I should not equal to -1, because it should be greater than or equal to 0. And then we are saying, okay, I should be decrementing. Immediately we execute to print out the value, I should come to 19. Immediately we print out a value, I should come to 18, until the point when I will come to 0, and from there it won't proceed with the printing out of values, because the next value will be, of course, a value that is less than 0, which is -1. And then we are saying, okay, see out stack I. Like doing this allows us to traverse each and every stack and print out the content. We even end the line. But if this doesn't happen, if this if statement doesn't execute, then definitely it means top is not greater than or equal to 0, meaning top is equal to -1 or -3, hence the stack is empty. This is what this, of course, function is actually doing. It is printing out the content. And in here, we just now have the main function, which is driving the entire process. Int many blah blah blah, which is the basic syntax for any C++ program and any data structures program with the C++. And then we are, of course, now declaring two variables, which is int select and int value. So when we do this, of course, we will use these variables because we need them definitely. So we are just, okay, choose option 1 if you want to push into the stack. We want this actual program to be menu driven, and we'll be getting content from the end user. And then, of course, choose 2 if you want to pop from the stack, that's if you want to delete. And then choose 3 if you want to display the content in the stack, or press 0 if you want to exit to terminate the process. And then we've implemented, of course, a do while loop. If you also want to understand what a do while loop actually does and how it can be implemented on its own, please double check the description. There are videos on the introduction to C++ as the sessions that discusses these as courses in C++. So we are saying, okay, whilst we have these, of course, as selective content, then this should be done, okay? See out, enter your choice. Immediately the user enters a choice, which is the choice that will be sent into the select as a variable. Then we'll use a switch statement to, of course, do multiple selections and, of course, the conditional needful operations for we to execute based on the content that we need to work on. So we are saying, okay, if the user selects, of course, A1, which is case 1, then Cout, enter a value to be pushed inside that stack. Because we know at option 1, we are pushing a value into a stack. And to push a value into a stack, the operation is simply the push as an operation. So the value that will be entered is simply the value that will be sent into the variable value. And that value will even be sent into the push function, which is the function to receive this as an argument in the parameters that are already available in the push function. We even break. So the execution of this case will proceed for as long as the user continues selecting 1, continues inserting in the values inside the stack. And then we are saying, okay, but if the user selects 2, then 2 will pop out the element from the stack. And if you understand, when it comes to popping out elements from the stack, it's the element at the very top, and the function for popping out will do its work. This is why we are calling the pop function. But if the user selects 3, then let's call the display function, the function that will display the total number of elements inside the stack. But if the user selects 0, then the program will be closed, and then of course press enter if you want to terminate. This is what a do while loop is actually also denoting down here. Okay, while select is not equal to 0, these operations should be happening. But if the user selects 0, then definitely the program should terminate, because we are saying while the select as a variable is not equal to 0, then this should be happening. And by default, if the user enters a wrong number, let's say 25 blah blah blah, which is not part of the cases here, then this should happen invalid option. So this is the actual implementation of the stacks using the arrays. And let's try to run this code to see how it's working and how it can, of course, be implemented. If we run, we'll see that it is a menu driven. So we've implemented, of course, the stack, and then it is definitely menu driven. So we're saying, okay, enter choice. Let's say I enter A1. Okay, enter a value to be pushed inside that stack. Let's say I want to enter 67. Then, okay, enter your choice again, 1. Enter a value to be pushed. Okay, let's say 42. Okay, enter your choice again, 1. Enter a value to be pushed. Okay, what value now? 7. So that has been done. So, okay, let's go on option 3. To display now the content, because we've made a program that is menu driven. If we choose 3, then okay, values in this stack are 7, 42 and 67. If we are now to pop out one element from this stack, of course we expect the element that was inserted in at the very last to be, of course, popped out, to be deleted from this stack. Why? Because that's what the stacks do, which is LIFO, last in, first out. To pop out, it's option 2. If we do that, okay, the popped element is 7, and definitely it was the last element to be inserted, hence it is the element to come out. If we are now to display, okay, 3 to display, we'll see that we are on the menu with 47 and 67. So this is the actual implementation of stacks using the arrays. And right now we can even terminate 0 to exit, and of course program closed, press enter to terminate. We even terminate the program. So yes, this is what's happening, and let's progress on our next session as we understand now the implementation of stacks using the linked list. Please don't forget to subscribe when you are on CodeNet.